Today we will be learning about compositions of transformations. Before we get started, it is vital that you're able to identify what transformation is required when written symbolically. Go ahead and start writing these notes down on your worksheets. Should be in front of you on your desk. Symbolically means that it's represented by a letter and not written out. So a translation will always be represented by a capital T. Have two numbers that identify the direction and the distance. Since reflections and rotations both start with the letter R, what differentiates them is what comes after the letter. Again, they could be lowercase or uppercase for either. So we know it's a reflection if a line is written after the R. So, the line might be y-axis, x-axis, x equals 2, y equals -2, y equals x, y equals -x. That's how you know it's going to be a reflection. A rotation is going to have a number, a degree written after the R. So you'll either see a 90, 180, or a 270. So it's pretty straightforward. So as you see up here, compositions of transformations are a combination of two or more transformations, and the second transformation is done on the first transformation. Now, what's important to understand is that whenever it's written symbolically, as you see here, you always do the one that's listed second first. So here we would reflect over the line y equals x, and then we would translate 1,5. And that's very, very important. If you don't do that correctly, it's going to be wrong. Okay. Let's go ahead and take a look at number 1. Okay. So you guys should already have all of the 1, 2, 3 graphed. Okay. If not, go ahead and do that now. But I'm going to go ahead and graph it, and then we're going to get going. Okay, so we've got x, y, z. So it's important that you not only label the points x, y, and z, but whenever you draw the second, and in this case third, figures, that you notate it with prime. Okay, x, y, z. So we are going to first reflect on the x-axis, and you may recall that, actually let's go ahead and highlight our x-axis. So we're just going to flip it over that. Okay, so all we're going to do is count how far each point is to the line of reflection and count that many past it. So that's going to be 1 right there. We've got y prime. 1, 2, 1, 2, z prime, and then x is 1, 2, 3, 4, 5, 6, 7 units from it. 1, 2, 3, 4, 5, 6, 7. Okay, and should have used. Go ahead and connect your dots to make your triangle. Should have done this in a different color, so I need to trace over them. Blue. Okay. All right, so if you're faster than I am, go ahead and translate this figure 9 to the right and 2 up. So what we're going to do is count for each point. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2. Okay. And then we're going to make sure to put your X, Y, and Z. This time you're going to put 2 little prime marks. So double prime. Look like quotation marks. Just like that. 2, 2, 2. Okay. And you got to make sure you fill in these points here and then these here. So remember, whenever we reflect over the x-axis, the x values change. Okay, or I'm sorry, the x values stay the same, the y values change. So for x, it's still going to be, what's it, -3. This becomes -7. Okay, y is going to be -2, -1. And then z is going to be -5, -2. And then probably the easiest way to do this is just to add 9 and 2 to each of these. Okay, so -3 plus 9 is going to be 6. -7 plus 2 is going to be -5. Okay. And then we've got -2 plus 9 is 7. -1 plus 2 is 1. -5 plus 9 is 4. -2 plus 2 is 0. Okay. So lastly, we will double check and make sure these 3 points are indeed these 3 points here. So 6, -5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Very good. 7, 1, 4, 0. We're in business. Okay. So that's number 1. Okay. Let's see. Let's go ahead and do number 2. Again, you should already have this written. So I'm going to keep this here in case you didn't get it all while I write out my W, X, Y, Z rectangle. So 1, 2, 3, 4, 5. Those of you who want to go ahead and start working ahead, we're going to do on this one, as you can see, we're going to rotate at 270 degrees counterclockwise and then translate at -7, 3. So you can go ahead and do that. You'll turn it 3 to the left. I'm going to get started as soon as I get it written. So we got 1, 2, 3, 4, 5, 7, 5, 7, 2, and 1, 2. Okay. Connect the dots. If you get how to do rotations, you're going to turn it 3 to the left or just once to the right. And then you are going to change your axes momentarily, plot those points, or rather log those points, and then flip it back to the way it was to begin with and plot those points. So let's see, this is 1, 5, W, X, Y, Z. So your original figure should have been here. Okay, so now we're going to go 1, 270 counterclockwise, 2, 3. Okay, and so I'm now looking, this is going to be my new Y. Oh, it's an ugly Y. And new X. Okay. So now I'm going to write down each of these points. They're going to be here. Okay, so I'm going to start. I'm going alphabetical order. So we got 1, 2, 3, 4, 5, -1. W is 5, -1. We got, so I know that's 5, and that's going to go down to -7. X is 5, -7. And then we've got Y is 2, -7. And Z is 2, -1. Okay. Then we've got, okay, so now we're going to go and graph this one. So we've got W is 5, -1. 1, 2, 3, 4, 5, -1. Okay, 5, -7. 2, -7. And 2, -1. So that's going to be W, X, Y, Z. And we'll connect the dots. Okay. Go ahead and write. We already get it done right now. Okay, so now we are just going to translate it 7 to the left, 3 right. So we're just going to count 7 left, 3 up. Sorry, 3 up. 1, 2, 3, 4, 5. Actually, use brown. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Now, I know that these are 3 apart, so I know that these are going to be 3 apart. I can just write that there. And then I can count off of this one. 1, 2, 3, 4, 5, 6. Count off of this one. 1, 2, 3, 4, 5, 6. I know the other one's there. Okay. So that's going to be Z double prime, W double prime, X double prime, Y double prime. Connect the dots. and then we are just going to write in the answer. Actually, probably the easiest thing to do is just to add or subtract 7, add 3. So that would be -2, 2, -2, -4, -5, -4, right, and -5, 2. Okay. Then we just double check, make sure these match up here. -2, 2, -2, 4, -4, and we're good. Okay. Okay, so for this one, what you're going to need to do is you're going to need to plot it, reflect it 180 degrees, and then, rotate it 180, and then reflect it -1. So just perform the rotation, then the reflection, and that's it. Okay, let's talk about congruent statements. So with congruent statements, what this means is you're going to have your beginning triangle, and you're going to have an ending triangle. Actually, let's see. And this is off. This should be JKV. And what you're going to need to do is write what's happened is one of these 4 transformations has happened. And you need to choose which ones happened and write the points, the pre-image, the image that they correlate with. Now, a glide reflection is pretty simple. Glide reflection is a combination of a reflection and a translation. Does not matter what order. Okay, doesn't matter which one. They're commutative, which means you can do either one first, and it will end up the same way. Now, when you're doing these, you kind of have to experiment. What I recommend doing is always looking first to see if you reflected one over whatever line. You can just pick whatever line. It really doesn't matter as long as it's a line that's between the two. You kind of want to look at the slopes. I can see here that the slope of EW, which is going to be 1, 2, 3, is going to be 3, and I can see the slope here. It's going to be -3 actually. Is going to be +3. So I know that this line could go with this one, and then I look and see here 1, 2 over 3, and the same thing here 2 over 3. So I know that this line is going to go with that one, and I can see now that that goes with that. So all that is a reflection, a flip over that. And then once that gets there, I can see that it's just going to be a translation up. Okay, so that's going to be a reflection and a translation. So that's going to be a glide reflection. Okay, and then really all you have to do, you don't even have to actually reflect it. If I know that this is going to flip over here and then move up, I know that J is going to go with E. So you would just write in E, it will go with J. And then you look and see which one goes with Q. So Q, when it flips, so Q will end up being W. So it's going to be E, W, V. Okay. These aren't too hard, but it does, require some thinking. And then you might have one like this, okay? And you want to look and kind of see, okay, well, if you always want to check, see if you're going to flip it first. If I flip that, no, that's not going to be a reflection. Then maybe you want to kind of see if you rotate it, what would happen. So let's see if I rotated this and I look. So if you rotate it like this, or I guess we're going to start with this one here. Now, if you see, that's really going to be a 180-degree rotation right there. And I can look and I can see the distance here is 3 units, and that's 3 units. That's 2, and that's 2. So that is a straight-up rotation, just like that, 180 degrees. So LMN is going to go there, so that's going to be a rotation. Okay, L will go with R, so we're going to have R there. M, okay, M is going to be the one that's directly down from there, so S is going to be with M. Line with M, and then the other letter left over is T, just like that. Okay. And that's that one. And then the last one is called a it's gonna be glide reflection, and you can use this graph to do it. And what you do is you pick any point you want, and you're going to first translate it and then reflect it, and then you're going to look and see which one of these goes with where we end up. And so once I do it, you'll see what I'm talking about. So you pick any point you want. You want it to be pretty close to the line of reflection. I'm just going to pick this point right here. Again, it doesn't matter. You pick any point you want. I'm just going to pick this one right there. Okay. So first thing we do is we're going to translate it 4. So that means we're going to move it up 4. So we're going to go 1, 2, 3, 4 right there. Okay. So if we start there, we're going to go up there. All right. So now it says that we are going to rotate it, no, I'm sorry, reflect it over y equals 2. So we're going to reflect it over this line right here. Okay. So when we reflect it, we go 1, 2, 3, 1, 2, 3 right there. Okay. And now this is our starting point, and this is where we ended up. So which one of these represents starting here and ending up there? So they're all reflections. So which line did we reflect over? Reflect over this one, the one that's in the middle. So that's going to be right there. Okay. Now you could have, I just want to show you how to work with any other point. Let's say we started at -1 here. Okay. We go up 4. 1, 2, 3, 4 right there. Okay. And then we're going to flip over this one. Okay, so start there, flip over 2, we end up there, and again, right back there. Okay, so it works at any point. Okay, so that's that. So you guys need to do both sheets, 3.7a, 3.7b. I have written this up here, so you know to make sure you do this first and then that. All right, good luck.